Okay. So things are coming up for you really quick. Trying to figure out the best way to do this. Probably the calendar. What's that?
You added a ton of files.
I did last night because I had to shift dates because I thought we had until the 22nd. You guys go on break on the 18th. You have a full. What's that?
And we're out of here.
You have 2 weeks for Christmas, and then we come back and we have about 2 weeks, which is mostly testing and certifications. So
certification, we hit state test.
yeah, so the state test, and then what we'll do is I would like you to, because I don't know how many of you back next semester, we're gonna do the SolidWorks certification. We're gonna do some prep for that. Most of you should not have any problem passing that at all. And so the challenge on both situations is getting you all here. We won't see the spike in COVID from Thanksgiving for probably another 7 days. So, yay.
Yeah, me and the boys had a good party.
I bet you did. Okay, so let me kind of show this up on the calendar to kind of give you an idea. You should see notices come through on your Canvas feed coming up. But mainly what you got coming up here is in December. Okay, so nothing really, I didn't put I don't think I put anything this week. Sorry, yeah, I did do a couple things. So you got a couple of, actually no, I didn't for you guys at all. Those are all architecture. So for your class, we're moving into dimensioning starting today, which means that the expectation is you're done with your modeling. And I know that's not true for all of you. I realize that, but I can't keep going back 2 weeks and moving forward one. We're about a month behind where I want to be. And I'm okay with that. We just aren't doing in one of the other projects. It's okay. So we're going to be looking at some dimensions, terminology, some worksheets on that. Tolerancing is a big thing, especially for those of us who are doing lightsabers and or alternate projects. We need to calculate those tolerances. Who are you? 91. No, 97. I missed the number. If you're 91, we have to call a doctor. I know. All right. So tolerances is a type of dimensioning that we're going to work through on this together. And kind of get you through there. There's a few quizzes, maybe your tolerance assessment, dimension assessment. And again, you're seeing architecture up here too, because it's my canvas, not yours. Pay attention to these calendars. You can do them early, and yes, you can still do them late, but don't try and do things over Christmas. You and I both know you're not going to do a darn thing. So let's not make it that way. Then you have the post state skills test review. Now, I want to explain this post test. It's the same one you did at the first of the year that I attended for you to take once and failed. And everybody had oh no, I can't go my grade. It says test on it, but it says free. Good night, guys. We're not doing proficiency learning here. This is a college course. Get over it. So the second round through, you will be able to take it as many times as you would like. The idea is, and I will tell you this one more time, I wrote the state test. This is as close to it as legally possible. So get familiar with them. You have 2 of them you're taking. You're welcome to take them both the same day, or we can do them on 2 separate days. We'll talk about that in this January. But what I'm going to do is these will close, and you won't be able to access them at all during Christmas. Okay? So they're open right now until the 18th. So you can do as many times as you want. I will reopen the same assessment again in January. So you can go through it before we do the state test. Okay? So you can put it back in your memory. Because a 2-week Christmas break means a total mind dump. Not that we're not fighting that all year anyway. But the idea is that you pass the state skills test, okay? The test, for those that end up being on distance, if you are not infected, I'll bring you in on Fridays at a scheduled event, meaning I'll schedule you to come in at a certain time for you to take the test. And so we've got maybe maybe 6 of you in here at a time to take tests. The test does not take, you're allowed 2 hours. Most students finish it with well below 30 minutes. The average is about 15 minutes, which is usually the ones that fail it. If you do 22 minutes, you're more likely to pass it. That's just been my history with it. Okay. So that's kind of the plan for all this as you get going through there. So you will have nothing due over Christmas break. Everything that's due is on the calendar now for you to get things done. And I know there might be a couple of you who still need things printed, lightsabers printed. We'll work through that, but ideally I'd like to have them all printed by the 18th so that I can shut the machines down. It's not good to leave them on for a full 2-week period because they get overheated. That's bad on circuitry. Those things sit at 270 degrees just waiting for the print, and that's not good. Okay, any questions on what's coming up? So yes, I did open up a whole bunch of stuff. I tried to space it out for you a little bit. Again, you can work ahead. Don't wait until Friday to do everything. Okay, that's kind of thing. Remember, midterms are December 4th, which is stupid because we're way past the middle of the quarter. It was supposed to be last week. They bumped it because so many schools were out. Well, when it was midterm,
we only had like 30 cases like last week.
I know.
I went over to some chick's house. She was like, "Yeah, our school's got like 31 cases."
Okay, she's not a chick. She did not hatch from an egg. She is a female part of the human species, so she's a young lady.
She's very, very beautiful.
Okay. Oh, goodness. Anyway, be careful, young one. What you say as a white male will come back and kill you in the future.
Chick? Have you seen the movie White Chicks?
Dude. Okay, anyway, so that's kind of the plan, is kind of get everything cleaned up by the 18th, okay? All right, let's move forward now that we're kind of in a quasi mood. This one is not, this is the demo one we're doing in class. This is the assembly, and what I want to do is pull that apart a little bit before I move in. And the reason I want to do it this way is we're going to move into some drawing sheets. And if I can get this set up ahead of time, it will help with what I'm trying to do. You can produce this completely without pulling it apart in the exploded assembly, but the exploded assembly will make your drawing a little easier for manufacturers to understand. And ultimately, that's the goal. We want everything we do to be buildable. Okay. Now, I'm not going to have you for this class dimension things like your embellishments on here or any of these decorative items. If it's a decorative item, I'm not going to have you dimension it for this class. Okay. Mainly because of time and how much we've got to do for the other stuff. So what I'm going to do here first is I'm going to go into my assembly view, and we're going to create this exploded view. We looked at this about 6 weeks ago, briefly, and found out that it's a whole new thing, which is always good. So all I want to do is I know my bottom piece is my parent piece. That's the first part brought in. So I'm just going to start with each piece that makes up this assembly, and I'm simply going to pull them apart, and I want to pull them quite a bit apart because it's going to take enough space. Oh, don't do that. This is what I did before. Okay, so we get that one, and then we're going to do another one, maybe. Oh, this thing drives me nuts. I do not like the new change to it.
Did you ever figure out that one problem you had like a while ago?
Yeah, it's the same one. It keeps resetting. And so we have to do different steps in it. And that's what creates the problem. So there's one. And I did this fine the other day, and I don't know why I'm going to fight me with it now, but it's going to. All right. Hang on. So ideally, you should be able to click on one, slide it forward. That should record a step. I'm going to just do that. And maybe what I need to do is set these all up ahead of time. So in your setup, you've got your chain happening. There's one part of it, and I need to add to that chain. That's ultimately the plan, is to add a step. So once I get it expanded out here, this is kind of the trick to it. So there's chain one. This is the proto C. That's in that step. I come down and add a step. Okay, so I'm going to click on this, add that step, and move that where I need it to be. And it gets a little, it's a little frustrating this way, but it does work. I do want to kind of somewhat try and align as I can. So I've got these steps that are happening here and moving things over. And each time you move, it's going to create a step. Okay, so when I do the next one, make sure you highlight the one you're at. Then I'm going to go to the one I want to change next, and then add the step. We didn't used to have to do the add step. So in older versions, you just clicked it, knew it was a different step, and that's the part I kind of miss, because it was just so much easier to align things where I wanted to be. Okay, so that creates my exploded view. Okay, when I'm done, I'm just going to hit the word done and check it off. And that's just stay there. Okay, now I'm just going to leave it that way for a moment, because we have to change topics for just a little bit. Okay, we have to set up our paper to print these off, because we can't. Well, it's nice to 3D print. When it goes to manufacturing or it goes to be patented, it has to be in drawing form. The patent office will not accept a 3D model anywhere. It has to be in drawing form. And it has to be very well dimensioned, because the size of things are what allow new patents to occur. So if I'm working on...
but you can't show them a 3D model? Because there's a guy in my neighborhood who said he works with like patents and whatever, and he said if you bring a 3D model to drawing, you're more likely to get the patent.
If you have with the drawing, you have to have the drawing, because that has to be filed. So if you have just the model, you're not there. You have to have that plus the drawing. Okay? That's what I'm saying. Is you can't just take, oh, look, here's my little rocket, make a patent for it. This is not enough. Okay? It has to have drawings with it. Okay? It has to have those drawings. Okay, so that's what we're going to do next. So I'm going to leave this where it is for right now. It's broken assembly, and it's only broken so that I can identify the parts easier. Okay? So if you're doing it would be something maybe a sleigh, maybe since we're doing sleigh, and you've got the whole thing done, you want to be able to show all the components of that sleigh, because a sleigh has been around for, what, 100, well, not 100, been around for at least 2,300 years. But we've been using sleighs for a long time. There's really hard to get a new patent on a new sleigh. So what we want to do is work that out to where we can say this is a brand new sleigh. And if you work in the bobsled industry, that's really key. Can you patent a bobsled? No. Can you patent the way you design the skis? Yes. Okay, so that's kind of what we're looking at. Okay, folks, here comes the hard part. While you're in your file, if we go up to File, New, you can go here, or you can go over to the page. Here, we're going to make a drawing from the part and assembly. So we've spent all this time making these models, and now we're going to convert them into a 2D representation. We're going to reverse that. And that's the big difference now with the way we design. We design 3D, usually from a 2D sketch or an idea, and then we convert it back to a 2D drawing. So we go ahead and click on make drawing from part. If you don't have your saver done, open one part at least, and let's go make drawing from part. Okay. Now, what we get here when you get to this point is you get the standard sheet sizes that are used in the industry, and they're represented for our country by ANSI. That's American National Standards Institute. That is a test question for both state tests, and you will probably see it at least 4 times. It is really, really important you understand that ANSI is the governing body for the way we submit documentation. So it gives us, if we're designing anything, it tells us how that has to be shown. So we have a couple sizes here. An A is a sheet size. An A is an 8.5 by 11 sheet of paper or copy paper. It landscape and portrait. Does anyone not understand the difference between landscape and portrait?
No, I didn't go to 3rd grade.
You didn't.
No, it's like the easiest question. Like, who doesn't know landscape and portrait?
Well, you'll see on the test when 6 people miss that one. Okay, so remember landscape has the 11 going horizontal. So that's the big difference on that. Then you have B size. No, the connection's bad.
I had to go back and realize that they didn't realize the difference between landscape and portrait. So they're like, oh, shoot, let's go Google that real quick.
Welcome back, everybody. We had a little power outage there. Sorry about that.
Ooh, fun.
Fun. Okay, now if you notice that once we get past the A, everything now is in landscape. Okay, until you get down to this A4. Now A4 is a metric size, 8.5 by 11. So when you get down to A4, that's where it changes. These A1s to 4. When we go up to the top, we have A through E. These are all in inches. And you have to be able to know the sizes of these. So if A is an 8.5 by 11, B is double that. It's an 11 by 17. Okay, so what we're looking at on here, let's see if I can get a way to show you more, maybe. I don't know. Oh, good. So it's not working. Okay, so I'm going to bring up my good old handy dandy annotate tool. And we're going to do some draw work. If I have an 8.5 by 11, and that is an A size sheet, then the B size is double that. So that's going to be an 11 by 14. So an 8.5 twice gives you 14. 17. So bad. Holy cow. Sorry, it's Monday. It's Monday. So 11 by 17. This is like a legal pad. Okay, then what's C going to be? 17 by 22.
Oh, you doubled the 11.
So we're keeping numbers going down here. So D would then be 22 by 34. And then we have an E size, which is 34 by 44. Oops. There's actually number sizes up to Z. So were you guys even born during the 2002 Olympics? No. I know, it's so hard to give references anymore. Have you seen like buildings will have the big banners that go down the entire side of a high-rise building? You see that downtown? Okay, that's when we get up to Z-size sheets. That's all one single sheet of media. Usually they'll use vinyl for those because it's a little more durable in the weather. But we can get sheet sizes, and when we print these, the roll of paper that we print on is 36 inches wide and 500 feet long. Okay, that classifies as a G-size sheet of paper. So as we move down these numbers, they exponentially get larger. And it is possible that you can work with this. If you look at only the old time city planning videos on YouTube, and I need to find the one that I'm thinking of. They used to do city plans where they'd lay the paper out on the floor and the architect would be drawing on the floor. because the sheet sizes were so large. Okay, all right. So for this project, we're going to use an ANSI B. I'm going to clear my screen here with this like ANSI B landscape. And I'm going to go ahead and open that up. Okay, now when we open it up, on the right-hand side, you're going to see your lightsaber in all its glory. You should also see the exploded isometric. That's what we set up ahead of time. If you don't do the exploded view ahead of time, it will not show here. Okay, that's the big key on this. Now, as we look at this drawing, there's a couple things about engineering paper that's kind of important. One is if you get a phone call from someone in, oh, who do you want, in India, and they're doing your manufacturing for you. And India typically does IT work more than anything, but they do have some manufacturing. What's that? They do whatever they're paid to do. But maybe we're having some manufactured, and we haven't manufactured in a different country. Rather than say, well, geez, it's about the middle of the page, and it's about, oh, you know, 3/4 way down, we have coordinate systems on our page. The verticals are letters, A, B. If we had a C size, it would be a C up here. And then we have numbers going across. Notice they go backwards. They start at the left, right, and go to the left. Okay, so this is section B4, B3, B2, B1, just like Battleship. So when you have a manufacturer call you and say, hey, I have a question about this detail in B3, you can go and look at that information and say, okay, I understand. This is what you need to do. Or maybe I don't understand this note that you put in A2. What are you meaning there? Well, A2 is my title block area. So if there's information here, then we need to be aware of that, okay? So we need to get everything adjusted so everything fits on our sheet. And what you do on this sheet will be all of your sheets. And some of you will have 6 sheets, some of you will have 10 sheets, depending on what you've done with your lightsaber and how that's going. And we are really having a hard time with the internet today.
Hey, I have a quick question.
Yeah.
I saw we were saying I was trying to draw something, and all of a sudden this like blue background came up, like around the drawing, and it wouldn't let me do anything.
In the
model.
model.
I closed out SolidWorks and opened it up. I took a photo.
Yeah, let me look at it a little bit here. Okay, so let's kind of zoom down this title block a little bit. It will have the name of whatever you name your file. And in this case, it doesn't fit in the title block. It's too large, okay? So that's one of the issues you have to be able to work with on this as you work it. We have a title area and we have a blank space above here. We're gonna go ahead and set this up to what needs to happen here so that it hopefully will carry through. But in order to do that, we need to edit the sheet. Okay, now this is where it gets a little bit cumbersome. It's meant because what we have here, we don't want to erase by accident. So over on your left, it'll say sheet 1, and then underneath that will be sheet format. So let's take a look at what we can do with our sheet as we move through this. If I right-click on sheet format, you get a whole bunch of information, like you can put a grid to it. You can edit that sheet format. You can lock the sheet's focus. You can add a sheet. You can copy a sheet. You can delete it. There's properties involved. And then there's also all your constraints that go with it. So your relationship to snaps. Go ahead and select Edit Sheet Format. When you do that, the part that you can edit becomes blue. Okay, so we have everything outlined in blue. This is what we can edit, and that's kind of a good thing. So now I know I can edit. Notice things have changed. I now have columns and grids like in a word processor across the top now, as well as a ruler going down the side. So if I zoom up on that, those columns will adjust to that zoom factor. And what we want to look through here is what we want to change. So one, there is a proprietary confidentiality statement given. As soon as you put your work on a title block with your name and a date, it is automatically copyrighted. It is not trademarked, it is not patented, but it is copyrighted. In 1990, Congress passed the 1990 Copyright Act, and it was mainly for the music industry. At that time, China was being a little more bold than they are now with ripping off music albums and then selling them wholesale. That Copyright Act meant that you have intellectual right to whatever you put your name and date on. So if you're working with a client on a new design, say you're designing a new bike or a new sprinkler, for those you're doing that, once you do a sketch, anytime you do a sketch, anytime you run anything in your design process, you put your name and the date on. If I'm doing a house plan and I'm doing sketches on notebooks or napkins, name and date, because that holds my intellectual right to that design. Okay, does it make sense? So here we can edit this text, and you can come down here and in the brackets, it will have, you have to kind of double click, you then get a text box, looks like so. When you get to black mode, you can come in and you can create either your name or your company name. This is my company. And then you can adjust your sheet and such so that you can get everything to fit into that box. And so you kind of work with that. Again, it's two places where that has to occur. And if you don't have a company, you can just use your name, and that works. And you just kind of get that in there so that you have that intellectual right. That's the first thing you want to always adjust on your title block. Make sure your name is there. Now, some companies choose to remove that. That's their choice. They do it another way. They do it with legal documents instead. But you do want to make sure you have that. And then do take the time to go in there and clean up the formatting so it's a little easier to read. You know, just kind of like you do for your English teacher that you hate. Make it look neat, okay? Just take a few minutes, because this is what people are going to start judging you by as a designer. Okay, then we have the application set here. This application is dealing with how this relates to something else. So if I was designing a battery compartment, and that battery compartment is going to be used on multiple products that I design. So maybe I'm doing night lights, and they have the same battery compartment for every night light. Then I would say, okay, it's on, this is where it's used, and it's used on this part. So this part of the assembly is used on this other project as well. You start cross-referencing your files so that when you have your office running well, you know to tell your employee, okay, go get part 7429, and that's going to go with 1830. And you start mixing and matching. So if you go into an auto shop store, you often find that type of thing happening where all the parts for one vehicle are cross-linked by number. And if they are universal in their nature, say like a light bulb, it's cross-referenced as well, okay? Then we have over here, unless otherwise specified, dimensions are in inches, because this is an ANSI file. If this was an international file, it would be in metric. And this talks about our tolerances, our fractions, our angulars, plus or minus, and notice there's these plus and minus. So tolerances are a deal here. Let's edit this now for what we're looking at here. So we're going to double click in this area again. So dimensions are in inches, and then tolerances are going to be a space, and we always start with 0.003. Okay, so we're going to 0.003 of an inch in accuracy for our tolerances. Our fractional values, okay, are going to be plus or minus. And the thing is we typically do not put fractions on an item, but we're going to put one here. We're going to go to nearest 1/64. Okay. plus or minus a 64th, which gets us pretty close to 0.003, but not quite. Go have angular for the machine and angular for the band. I usually leave these blank because I'm not doing any angles on the lightsaber. So if they're not there, don't do them. If you then do angles, then we want to put those in. These are degree marks. And so in order to understand that, I usually do not do any degree. That is, again, 0. Notice my tile block expands. If I'm machining it, I'm not going to go any more allowance than 0.02 on that. Back that up. And then same on the other side. I'm doing a bend. And now I notice I'm not quite fitting anymore. So these red marks that you adjust your title block, your title box, I should say. And I'm just going to do a return. And I'm going to tab that over. And so it lines up with machining. So it's a little bit of a weirdness there, but I don't know where to keep it from. So I want that to fit. Then I can pull my title box back, my text box back. Okay, so if I'm using 2 places of decimals, that's going to override this. So if I'm doing 2 places of accuracy on a decimal, again, start with a 0, because the decimal point may not show up if they Xerox this, or even if they photograph it. We want to make sure they understand there's a 0 there. And let me get this back over here. It's supposed to be. So if I'm going to 2 places of accuracy, that's 0.0. Let's go 2 there. And if I go 3, 0.0003. So I keep that in mind. Okay. So I'm a little bit tighter or a little looser on the 2-place accuracy, but a little tighter here. Okay. And this will all come from working with your engineers and design charts. And we'll look at some of that today as we go through. So this is kind of a heavy lecture day. So apologize for that, but not really. So we have that. Now, once you're done, click off of it and it's set there. So this information now, if it's here in the title block, I don't have to put that on my drawing. It's taken care of, and that's just saving some time. There's interpret geometric tolerancing. I usually leave that in blank. And then we have material. This is a hyperlink. So when we assign a material to your lightsaber, it will stay there. So I'm not going to worry about this or the finish because we have not assigned that yet manually. I'm waiting for you all to get them done so we can do this all at once, and then we'll get that assigned, okay? So kind of fun then. Okay, sliding over. This is going to be super duper important. Your name needs to fit in here. Now, here's the deal. Your names will not fit in that box. So now we've got a little bit of a problem because some of you have the same initials, which makes it really difficult to figure out who's whose. So if you're going to add text to a box, which is what we're going to do, which is why we're doing this, I need to go to the top of my screen and hit annotation. Annotation is the proper word for text and numbers. And I'm just going to put a note. Just going to add a note. And then bring that note over to my text box. Now, if you hit a line, you're going to get an arrow to it. It's called a leader line, which is great for the drawing, not so great for the title block. So if I'm trying to get that in there, I've got to position it so I don't get the leader. And then I'm just going to put in my initials. That's all it's going to. Now that is going to be way too tall. I can see that already. It's not going to fit well. If I click off, it'll work. But now notice anything else I do is have that same text. So be aware that once you start typing things, it's going to be the same. Okay, so I have to go back in and make sure you hit the green check mark to end that line of text. And you might end up with extra ones on there. Just select them, maybe. Get that to go away. Weird. You could make an annotation. Note. Oh, it wasn't there. It was a ghost. And then put the date in as well. Now the date, this is kind of a tricky one because it is dependent upon your office standards. So in some offices I worked in, you put the date you finish the project. Others, you put the date you start the project. We then put the date you finish the project. Okay, so again, you want to get your text box. If you have a hard time getting rid of that leader, put it up above. And this is the format we're going to use for our dates. We're going to go the month slash the day slash and the last 2 digits of the year. Now, we're going to have a problem in about 80 years. Okay, and here's what the problem's going to be. CAD software is only started in the 1900s, so 1980 actually. So we know that if we could have this be 1920, it would not be 1920. We know that because of the nature of the drawing. Once we get to 2120, we're going to have to start including all 4 digits to the year. Does that make sense? So your office may say, nope, put the full year in because they want to avoid that problem with archive drawings in the future. Some of you that go and work for an engineer, your first job is going to be cleaning up the archives. That might mean going down and actually moving drawings and file folders or opening up the digital files and making corrections to those. Okay, now once I do this, however, I am pretty sure that if my initials fill the box, this is definitely going to fill the box. And yay. So now I can take and move that down, but it doesn't fit. It needs to fit in the box. So there are a couple of things you can do to make things work. These, if the lines are blue, you can edit them. And I know I've got a little bit of room here. I can slide this over and I can slide the name, keep it lined up. There's a little yellow preview line there. You can slide these elements around. And so you can get things to kind of fit. And that's about the most I'm going to be able to do there. So got that one off filter a little bit. So I still don't fit. So the next thing to do then is double click on the font. And you're going to get this element come up. Right now it tells me it's 0.13 inches tall, which is just over 1/8 of an inch. Well, 0.13 is great, but if I just change that to 0.12, it's moving down just a little bit. Or I can go 0.01. Oops, too many zeros. 0.1. 0.1 is a fit inside there. Make all your text the same height if you do that, okay? You don't want to have multiple fonts the different sizes. You want them to read the same. So then you have a standard. You're trying to create a standard for your quality of work and how it looks, okay? Now, the next would be checked by, in an office, you would have someone check all your work to make sure nothing leaves the office with errors on it, especially in engineering. If you're off on your numbers, then you could cost, well, in some cases, if you're doing Xboxes right now, and you're off on the housing compartment, how it fits, if they don't fit and you have to redo the 5 million they made, that's going to cost you some money. You're probably not going to have your job very long. They produced 5 million of the new Xbox. They're all sold out. They're not sold to people yet. They're bought by robots. And then they sell them back. So you can still find them, but you're going to pay 3 to 4 times as much for them.
Like, hold on. So the AI buys them? Like people set up robots?
Yeah. The same way they do with concert tickets and stuff like that. Yeah. Everything's sold digitally. I mean, there's nothing stopping that. It's not illegal. It's a little unethical, but it's not illegal. So in your office, you would have someone check your work to make sure everything was done to the standard and to accuracy. So you're gonna leave this part blank. Then you're gonna have the engineer's approval, the main engineer designer. This is, you'll see this a lot, especially in gear parts or machine parts. Auto industry, this is huge. In the auto industry, there'll be 17 more checkoffs because you have to make sure that when you're working on a series, so like the Ford Mustang, each year they only change very, very little parts to that. The rest of it all has to stay consistent. And so you have to have checkoffs in all of those. Then you got your manufacturer's approval that says, yes, we can make it for the price we agreed upon. We have the tools set up, we have machinery set up. Then there's a Q&A area. Who do you contact if there's a question? Okay, that's usually going to be the lead designer on the project. And then there's comments. So things like, hey, well, let's put one on. Well, we don't have one that we set up. So it might be something that says all fillets are 0.25. And that. Okay, so Mustafa's giving me a text chat here. Okay, so in your comments, there'll be things that are standard for it. So you might say something about, well, we'll do this one. I think this is one that exists for a lot of you. I'm gonna put a little text down in here. And on this it says all fits. And get my fingers in the right place. Are friction. Yeah, I'm getting there, man. Hold on. Disparage me later. So that's a legit note there. It reads funny. Yes, I know that. All fits are friction fits, meaning it just slides together. I didn't do any threads. I didn't do any fancy connectors. There's no peg and hole system. It's just a friction fit. Okay. Because the manufacturer is going to question you. How are you holding this together? Well, it's just to be a friction fit. Or it could be all fits are glued. If you're going to glue them all together, then you have to say, they're going to be glued together. I know it doesn't look like they're going to stay connected, but my intent is you glue the thing, okay? Because that will be a different set of costs to the manufacturing. If I've got to go through and have someone glue these all together before I ship it out to sell, then I need to include that in my estimate of cost and in my bid, okay? Now, this title is a spreadsheet description form. That will happen after we bring drawings in, so don't mess with this. This is a hyperlink to your file. Then down here is your assembly. Well, that doesn't say a whole lot. You can edit the name. Again, double click. And we can get that font. I'm just going to change the name. And notice I'm now working in capital letters. That is industry standard. We do capital letters. Why would we do all caps?
Because it's important.
No. Here's a couple things to disparage your poor English teacher. Okay, one, if you type an email in all caps, you're yelling at people. That is what it defines as. If you do all caps, you're yelling. If you bold all caps, you are furious with it. Okay, in engineering and architecture, we do all caps because it's easier to read. If I had a lowercase e and an a here, and I Xerox this sheet, and I did it a lot of times, maybe it was a third generation copy, I'm not be able to tell the E from the A. It's gonna get all bunch of shadow effects and toner marks. And so in our industry, we do all caps for easeability of reading. It keeps making mistakes. The only time you lose a lowercase letter is if it's part of a catalog part number. So if I need to order battery E724A, it would put in lowercase and for the E because A would most likely be capitalized. So if it's a catalog reference, I match it exactly as the manufacturer says to use it. So I get the right part because capitals mean things in our industry. but for what we type, that will always be all caps, okay? Now, what I like to put in this top blank right here at the top of your title block is your actual full name. Again, mainly because there's a few of you here have the same initials. So it's another note, and it's just here in the top, and just type out your full. And you have to remember not to space. Takes a little bit. Just put your full name there, just so it's quicker for me and gets us there, okay? Now, this here will happen with your title block size. If you change your title block size, this letter will change. And down here, it's to have our, so I can't remember what this is down here now. The weight of your object and the scale. Right now, the scale of this drawing is 1 to 8, which means it's an 1/8 of its actual size. Well, that's probably not going to work, but it's going to work for what I need right now. So we'll look at these as we get more of you finished with your lightsabers, okay? Because you're going to render them out as well, because we need to do some rendering. And somehow we're going to get this all done in 2.5 weeks. We can do it. Okay, so that's all to have you change. Let's talk the revision box right here. If you get your lightsaber done, you print it and you come back and say, hey, Dr. Paskett, I really messed up. I gave you the wrong part and they don't fit together. I need to redo this. Then we'd have revision 1. So we always start with no revision, and then we number each revision so we make sure we keep the drawings correct, so that if we have to reproduce it, we're not getting the wrong file out there. Really, really important to keep track of revisions, especially as things evolve over time. So if you look at like Air Jordans, the shoe, how many versions of the Air Jordan shoe have been produced since Michael Jordan played in the NBA? Okay, each one has a revision number. Okay, because Nike can go back and reproduce any shoe that you want them to. Everything can be rebuilt. You just have to call them up and pay the special processing fee, but they can redo any shoe they've ever made. It's all in their system because they have all their revision numbers. Super, super important, because there are some people out there, mainly people who make a lot more money than I do, that will only wear one type of shoe. And they have to have that shoe for every game, or if it's not lucky and they're going to lose. Shaquille O'Neal is one of those. Okay, he's worn the same type of tennis shoe his entire career. That's the only one he'll wear. So they custom make the shoe. Okay. All right, so we're there. Now, we need to get out of the edit mode that we're in. So to do that, you can right click on your screen and you'll see, oh, wow, there's really not a whole lot going on there that I can change things with, okay? If you're over the side, you get one set of notes. If you are over on the drawing and you right click, you get a different set. So if you go down, you'll see edit sheet again. If you click edit sheet a second time, it takes you out of the edit mode. It's a toggle. It's either you are or you're not. Okay, you can also find it under sheet format. You can edit the sheet, or you can right click and hit edit sheet again, and you're out of the edit mode. Okay, so that's how you get out. You just reverse what you did. Okay, so everything's down in here. Let's talk about this scale issue. Your lightsabers are supposed to be 12 inches or less, okay? So if my drawing is 22 inches wide, because it's a B size, I should be able to fit the whole thing on in real life time. That's really assuming an awful lot. So 1-to-1 would be great. Now, for this first sheet, that's probably not realistic because I've exploded it and pulled it apart. I'm probably closer to 20 inches wide with it now. So I'm going to change the scale of this drawing. So I'm going to come back over to the sheet. If I look at the sheet 1, it says sheet format, and I right click. Oh, wow, look, I get the exact same tools. The same tools come up again, and that's intended, but you need to make sure you're clicking the right place. They look exactly the same, but this time I want you to go down to properties. Okay, so we go to properties and we get everything about the sheet that we want here. There's a lot of information here, and a lot of it applies to your state test. So yeah, we're getting down to where it's all getting exciting. Okay. One, it tells them I'm sheet one, and I'm going to leave it sheet one for right now. I can come back and rename the sheets anytime I want. And I would do that so that I know what I'm looking at. And as we finish through this week, we'll do a lot of renaming. Okay, so just be aware of that. It's a good exercise to use. It's the same process you use for Excel, for those who have the Excel class. The same process you use if you do multiple PowerPoints. It's what's the standard Windows activity. But here's the scale, 1 to 8. I want you to change that 1 to 2. So it's a ratio. That makes it, what is the scale then? It's 1 to 2. What would that be? In a ratio form. So, what's that? Yep, 1 dot dot here. Let's see if we can teach you some quick math. Okay, yay, math. This is right now 1 to 2. If I convert that ratio to what it really is as a fraction, it becomes 1/2. It's the same thing. It's still a ratio, right? So we just take these two dots, put a slash through it. That's a division problem. That's all a ratio is. So we are now at half scale, is what we're doing. Does that make sense? So if I do 1 to 1, that's full scale. What if I do 2 to 1? What's that? It's double the size. Okay. So you'll see that happen, especially doing small things. You might see 4 to 1 if you're doing watch gears. And we're now seeing a real resurgence of people wearing watches again. For about 10 years, the watch industry thought they were going to die and go away. And now all of a sudden we like the fashion. Guys get more back into fashion and wearing watches again. So it just depends on kind of what is going on there. So if we do 1 to 2 at half scale, and so we can move on from there. You can change the size you're drawing in the middle of your work and change everything. We're not going to do that today, but you could. Okay, over here is the projection stuff. And this is probably the hardest thing for Americans to understand. Okay? We are in the United States, we use third angle projection. So the best way to understand that is if you walk up to the front of your car, you're on the outside of the car, and you're looking at the car. Which side is the driver on? The right side, okay? That's third angle projection. That's you looking at the object, okay? Now, get in the car and look forward. What side is the driver's side? Left, because now you are the object looking out, and that's first angle. So first angle is you are the object, and that changes left and right perspective. Doesn't change front and back, it just changes left and right. But if you are in third angle, that's you looking at the object. Only the United States is third angle. The rest of the world is in first angle. Okay, so just kind of keep that in mind. Third angle, first angle. There is no second angle projection. Well, there is, but it's really weird, and so we're not going to talk about it. You're actually looking at the object from the top, from the top view, and that doesn't give us any information. And then fourth angle is the bottom view. Okay. All right, go ahead and hit apply changes. And if we look now down at our title block, the scale has changed. Our sheet number is still sheet 1 of 1, but we haven't put a weight. And we cannot get a weight until we assign material, finish it. And so that will be coming as we go. Okay, so my title block is ready to use. Woohoo! Now the fun begins. You will have eventually a rendered image of your lightsaber on this first sheet. Okay, but we also need to explain how what is on the sheets to come. This is our title sheet, meaning it's going to be just like you would do in an essay or a novel or a book. we have to tell what we're going to look at and where to find each element. Now, remember on the right-hand side, I used to have a whole bunch of stuff there. That's kind of gone away as we worked on things. So over the right-hand side, you have a little house. That's your resources. Then you have the design library. We'll look at that probably next week. Then you have a file explorer. Woohoo, that's kind of cool, which is just like the one at the bottom of your sheet. Then you have your view palette. That one's gonna be important, so remember view palette for right now. Materials, you have your custom properties and your SolidWorks form. The form is kind of like, hey, I've screwed up my drawing, how do I fix it? And people who are nice will help you, and people who are not nice will make it even worse. So read carefully in the forum. There's some real jerks out there. Okay, let's click on the view palette. Oh, look, everything's back. Woohoo. Now, all of these are the assembled drawing because that's what's currently open. And it has my front, my right, my top, my back, my left, my bottom, then all these isometrics and the current view and the exploded view. I did the explode view intentionally, so I take the explode view and I click it with the left mouse button and then drag it onto the drawing. That is not the view I saved, but it'll work. How nice. Okay, now if I look at that and I look at my exploded view, that really wasn't the one I wanted, but so let's go to the current view and see if that one's better. Oh, no. So I'll put both views on, okay? Basically, they both will work what we're doing, and maybe it'll be easier if we just skip the exploded view. I don't know. I like the exploded views when they work, but when they don't, they're kind of a pain. So I have my views on here, and go ahead and put one or two views on your sheet so we can talk about what we can do there. Now, when we look at these, obviously I'm missing what I thought I had saved, and I apparently didn't save it right. I could probably do this. Go back into assembly and just hit save. Well, it didn't save it, did it? Huh, interesting. Okay, never mind. Don't worry about it. Don't worry about the explode view. I've got to practice it better so I can teach it better. I messed that up enough. I'll take full responsibility for being stupid there. So if you get a view in that you don't want, your cursor floats around to get an orange outline of the viewport. Okay, and I know this is boring. It's a hard way to come back from vacation, but if you don't want it, you can select it, right-click, and then you can delete a view out. And it'll say, do you want to delete that view? It's going to prompt you because you don't want to delete things you're using. So I'm going to hit yes there, and that view is gone, and so I have this view left. Now, you can also go in and take a view, and you can copy that view. So up here at the top, if I'm in my drawing area, I can take that view, and if I hold the control key down and drag, come on, do it. Oops. There you go. Nope, not what we do it. Why did they take copy away? There it is. Copy the view. Paste. There it goes. So it gives you a warning because sometimes, depending on how you've done your features, they may not allow you to copy them, especially if they're hidden. So now I have two of the same view in that. It is the view that is in the drawing. I can take one view, and if I go to the side, it will show me that they're in standard view orientation. So there's my view orientation we've been using. But down the bottom, if I switch it to the shaded edges, I can get a shaded rendering in there. Now, ultimately, we want to create a rendered image to bring in, so it has some color to it. But this will give you one view of that. Typically on your cover sheet, which is what this is, you would typically show a shaded view of that. And that shaded view, because it's not easy to see everything on it, would maybe have a different scale. So I've got it's highlighted blue, so I know it's there. I scroll down, I can use a custom scale and change that to 1 to 4, so it's a little smaller. And when I check that off, then I can move this view into different orientation. Again, it's just a thumbnail right now to show what's going on here. Now, what you want to do is never put your drawing in your title block. Okay, that's considered a real big no-no. But I now need to set up a table of contents for what's going to happen here. Okay. All right, are we with me still? Yoda's still hanging in there, Kaden?
Yeah, I'm still here.
Oh, good. I'm so glad you're having fun today.
Thanks.
Yeah. Okay, now this next part's pretty powerful part of SolidWorks. I'm in the drawing. It's the drawing tab itself. As I go across the top, there are projection views that we'll look at as we get to the next sheet, and section cuts and relative views and standard views. We'll look at all of these throughout this week, even though it's only 2 days that I have you. What I really need to happen is a title block. So if I go to annotation and I look what's in there, because the title block would be, or not title block, table contents would be a calculated issue. And if we go over to tables and hit the down arrow, there is a general table, which is literally just a list of parts. So if you had, let's see, it's Christmas coming up, and let's say you're building an easy bake oven and you had to assemble it yourself. You would have a chart that would then list how many screws you needed, how many of each one were given to you, their size. They give you how many wrenches were included, how many bolts were given, how many washers. That would be a use for a chart. We're doing a bill of materials. Every assembly must have a bill of materials. That's kind of what it is. So go ahead and click on bill of materials. And when you look over the side, it's to have BOM. Don't get that confused with the local religion. It uses those STEM acronyms. It can be top level only, parts only, indented, attached to anchor point. It's got all this justification stuff. Really what you're wanting to do is bring that in. So I'm gonna hit the check mark and I just slide this over. It's all filled out for me. And I usually it almost always goes on top of the title block, or more preferred is the top right-hand corner of the drawing. And it snugs in right there, okay? Now, every part that's in this assembly is listed here by file name. So if you change the name of your file, these will change, okay? So this is by how you name it. It tells you how many of those there are, and then you would add into the text, you could type in a description of what's gonna go there. And we'll keep the link, and we would go in.
Sorry, can you show me how to get the bill of materials real quick one more time? I was trying to fix something with my design.
Sure, can do.
Okay, thanks.
Okay, so the bill of materials is under tables and annotation. So your annotation tab, tables, hit the down arrow, bill of materials. When you select it, you can only have one per project, but it's then just to give you justifications, then turn that off and hit the check mark and bring it right in.
Awesome, thanks. Awesome, thanks.
Now, here's where this gets kind of cool. I need my manufacturer to know what things are working on. This is also going to be the order in which your sheets will be created. Okay? So if I come in now, I'm going to come up to the top, I'm going to find balloon. Okay, and a balloon is a labeling tool. So I click on the balloon, and when I come down, I select a part. So down here, my battery compartment. That's 5. 5 is proto A. Come down here lower. There's 1. Moving up the next part. There's 4. There's 3. Wow, this changed. There's 2. Okay, so now make sure I got 1 through 5. There's 1, 2, 3, 4, 5. My drawing is now labeled. So I know what each piece is. They're not in order because they weren't created in order. This is the order in which each part was made. Okay, so that tells me a lot about a drawing by where the engineer's process went, what they did first, what they did second, and how that was worked out. And so now I'm good with that process, that I can now start my next sheet. So bill of materials, labeled part. Okay. I'm going to give you a minute to catch up with that part of it. Now, like I say, we're going to leave some room on here to place our rendered image, colored image over here. If you can, you just kind of position the sheet so it looks clean. You want a good, easy to read sheet of how things are looking. Now, one last thing I need to do is anytime you put an image on a drawing, it needs a label. Okay, so I'm going to do another note. And then come over here and then place it under or near. In this case, I'm going to go under because I've got room to do that. And then label it. This is going to be, and again, all caps. Lightsaber assembly. I'm going to highlight all that. Where's my text box go? Highlight that. Titles. Where'd my box go? So the problem with having too many screens. There it is. It's underneath the text. Your general text is going to be either 0.12 or 0.13. Your titles will always be 0.2. They're almost 1/4 inch, but they stand out large, so they're there. And I'm not sure why I'm getting the shadow fonts, but that's happening. Cool. I don't know why. That's not really there. It's just it's probably your video cards if you're here in the class. They're leaving these shadows, and I'm not sure why that is. Well, I do know they're 7 years old. They're dying. So you want a title underneath it. If the scale changes, then we have to tell what scale it's at. So my drawing scale is 1 to 2. So let's go up here. Let's go back to annotation note. There it goes away. And the note for this one is going to be the same thing. And then just lightsaber. Zoom up there so I don't spell everything wrong, so you can see what I'm doing. Shade. And that will be a font. So I highlight that. That's in font 0.2 again. While that keeps moving. Okay, so I put that there. And then I check that off and put another note right below that one. So right below it. And this is going to be the scale is 1 to 4, because that's what we changed it to. That will be the standard font of 0.13, because this is a different scale than everything else on that drawing. So I need to make sure I label it correctly. If it's the same scale as your sheet, you don't need the scale. But when you have a different scale, you need to say, hey, I've changed the scale. This is what it is. Okay. Okay, wow, this is a lot of work. You guys feeling mind dumped on? Some of you are falling asleep. Too much turkey this morning. We had duck. It was good. A lot less meat. Donald died. Okay, that is the start of your title sheet. Okay, so that's one sheet. Now we need to start putting in our parts. So I have sheet 1, and I go down to the bottom where it says sheet 1. I will right click, and I'm going to add a sheet. So click add a sheet. It'll say sheet 2. And notice everything's gone that you spent all that time doing. Oh man, that's a bunch of malarkey. Oh, even my scales stay the same, but my title changes, everything changed that I got all pretty. So here's how you're going to do it. That's what happens when you do add sheet. I'm going to delete that sheet. So bye sheet, thanks for being there. And what I'm going to do is come down to sheet 1 and I'm going to copy the sheet. Just to do a copy of it. Copy. Oh, come on. No, you got to copy. Okay, I guess you're not doing copies anymore. A lot of software changes. That's no bueno. That's very bad because it's a lot more work this way. All right, so now I got sheet 3. Happy day. You're going to have to edit your sheets. They've taken out the copy sheet command. So sorry about that. That'll work though. And that's okay because I'm not going to use this assembly anyway. Okay. I don't want this assembly. I want on my next sheet, I want it to be part 1, which is the battery compartment. Okay. For this one. Whatever your 1 is your next sheet. Okay. Does that make sense to everybody? So whatever your part 1 is, that's your next sheet. You will have to go in and then rename the sheet now. So I do right click, rename, battery slot, so it matches what's in my bill of materials. Enter that in. Sheet 1 will stay sheet 1. We'll change that a little bit later, but we're going to leave that at sheet 1 for right now. In my battery area, if I go over to my view palette, oh, there's nothing there. Now, here is the beauty of what this is. It's still trying to find the assembly, but I've already used that assembly for another drawing. If I hit this down arrow, I can scroll through all the files that are currently open. So before you guys came in, I opened up all the files for the lightsaber. I can now scroll through, and the battery compartment isn't in the list. How nice is that? So if it's not in the list, if you didn't open them, there's the 3 ellipse dots, and hopefully English teachers taught you about ellipse dots, because that's what it's usually taught. It means there is more of. So we click on the ellipse dots, and what that's going to, oh my gosh, what is going on here with my network? It's going to bring up your Explorer and let you go back and find where you have saved your part. And I put it here. I don't know why. So I open that up. There are all my parts now shown. And this is the last part I'm going to show you today. Okay. And then I'm going to give you some time to work because I know some of you are going, I haven't had to work for 2 weeks. I'm dying here. Okay. All right, so my battery slot comes in, and it's got top and front and back and right. The way you place these in your drawing is super, super important. Remember, we are 3rd angle projection. So I'm going to bring it in from the front. I'm going to take the front view, and then bring that in first, place it, go up above it, that's the top view, and go to the right, that's the right side view. These 3 views have to happen. Okay, you want those 3 views. Now I'm still 1/2 scale on this sheet. Notice on my side though, there's sheet 1. There's my battery slot. And then right click and then edit the properties on that sheet and go 1:1 and apply those changes. So this sheet now has a different scale. Let's pull these apart a little bit. Okay, now this is the battery slot. This needs to be dimensioned. There's a lot going on here. And this is where you're going to spend a lot of time. Okay, and I apologize, it's a lot of time. This is probably the boring part of what goes on in this world. Notice when you move the alignments, the things that are aligned stay aligned. So you can position things out, but they have to stay in alignment. Dimensions that are common go between the views, okay? So let me illustrate what I'm talking about here. We'll come back. I'm not going to do all the dimensions on this today, but I'm going to do quite a few of them because there's some things that have to happen. I'm going to use my smart dimensions here to dimension things out. I'm going to start at the top view and do the diameter. And this diameter needs to come out as a dimension because it's the same value for the view below. Okay, so I look at that and I say, okay, it's going to go between these two views. So it's the same. This outer diameter is a set value. It has to stay the same. If I do the inside diameter, that slides. I'm trying to remember how this one goes. This one slides. Nope, this one's the one that changes. This one's the set one. Can't remember how I did this. So you got to float around there till you get your diameter. Come on, do the diameter. There you go. And when you bring the next one in, don't line the text right up on top of itself. That's considered a no-no. Stagger it over because your eye can read that better when they're not directly lined up. Okay, so let them stagger a little bit. What happens on this is this slides up inside the other one. So there's a tolerance on this one. Remember, we did a tolerance of 0.003. Okay, so I'm going to show you a tolerance here. The tolerance means that there's an allowance that it can be a little bit bigger, but not smaller, or a little bit smaller, but not bigger. So we're saying you can do it, but not do everything you think you can do. So I'm going to change this one right here. So I click on that dimension, and over on the side, it says my tolerance precision. So I go into that and then do, it's called a limit tolerance. Okay? A limit is that maximum minimum tolerance issue. So I click on limit, and then it says, okay, it cannot be any greater than this because it has to fit into the next part. Okay, so you have to know how your lightsabers are going together. It cannot be greater than that, but it can be smaller by 0.003. So I put that in my minus area. I click in a non-text area to see what that looks like. Come on, catch up. And I'm not going out to 3 decimals, so it's not showing. So I got to do some fixing. I'm not seeing 3 decimals. And so my tolerance doesn't show at all. So now we have to go up to the gear. We go to our options. Our options brings up a new panel, looks like this. We go down, we say there's display. There's a lot of fun stuff we'll do here. Probably a lot more we'll do in January with it. Yeah, it'll be January. I don't see anything here that has anything to do with my dimensions. So I go to document properties and to dimensions. And when I get onto dimensions, now I can look at my precision. And I want to go 3 decimal places. And I do want you to do your decimals all to 3 decimals. So that's going to be a non-negotiable. Okay, no problem, kid. So we're going to do 3 decimals. And let's see what else we can change along here. You can change arrowheads and stuff. We don't need to because they're set to ANSI standards. So that's good. And we can change our font if we wanted to. You can change your font. Try and stay in the Gothic style. That's kind of the traditional use we have here. And then I go, so all I have to do is go to 3 decimals. So I hit OK. It updates, and now I can see the difference. And it also shows me a couple something else that's going on here. This is not exactly the size I thought it was. So if I notice, I've got some different sizes in there. So I'm off a little bit in my own design, which, yay, kind of sad, but it's good to know, okay? And it works, it fits, so I'm gonna stay with it. So because these apply, now this 1.575 value applies down here as well, but I can't see where. Okay, so now I'm gonna go to this front view. I'm gonna go over to my display style, and then make the hidden lines visible. Okay, so there's the lines go inside. Now you want to show hidden lines so we know that there's hollowness or that there's a cavity in play. But here is the thing that will cause you to fail these drawings like no tomorrow. You never, ever dimension a hidden line. These lines are great, but this could be a square. In fact, on the battery compartment it is. So you never dimension hidden lines. They're just there to convey this is a hollow or a shelled out area. Don't dimension hidden lines. Okay, we find other ways to get that information. Okay, and I'll get through that as we get through here. So I've got my diameters. I now need the battery compartment. So I'm going to go back to my dimensions, and I've got radii on my corners. I don't know why. I just rounded them off. I thought it was kind of cool. So what I'm going to do is show you how to dimension those. I'm going to take this one here because it's kind of up and out of the road. I'm going to bring that up to here. So I've got a radius of 0.12, and I'm going to come down to the dimension text box on the right. Click in front of the R. R is for radius. And I'm going to put, in this case, there are 4 of those. So put a 4, X, space. That means, and that X should be, yeah, just like that. That means it happens 4 times. There are 4 radii of 0.12. Now, that means that the person looking at the drawing needs to have a little bit of a 3rd grade intelligence level to count to 4. Okay, so I check that one off. I do the same thing with the inner one. It's another smart dimension. Get the little guy on the inside. Now, you never do a radius straight out. It needs to have an angle to it. So you might have to position it. Those angles can be 30, 60, or 45 on leader lines. That is it. You do not ever do a straight shot leader. Okay. One, if you're doing these on a plasma cutter, those will be cut. It'll cut them every time. And then you've got this big old gouge or cut through your material. So you do need to make sure that you're at an angle. Oh, this is bad internet today. And again, I'm going to come over to my text area. In front, add the 4X, because this also happens 4 times. And check that one off. So now those are all dimensions. So when things repeat, use the count. Use the number and the count. If you're doing octagonal sides, you'll have 8. Hexagons are 6s. And I've got a center line going through. If your center line is not shown, you can bring the center line up here by coming up across the top and doing a center mark right here at the top. If it doesn't show those, make sure if it's, because anything round needs a center line in the view that shows round. If it's a round object, you always dimension it where it shows as a round object. Don't give the diameter down here. Okay, we don't ever dimension that diameter down here. That's why it's in the middle. Okay, so now I'm going to do the other dimensions here. I'm going to start with them based off the center point. So I'm going to do 1 from here to here and pull it to the side. So that tells me from the center up, and then I'll do an overall and that side's dimension. I'll do the same below, and I'll go from, let's see, go here, pull this one down. Now that's kind of tight, so bring the text out. If it feels tight, go ahead and slide it to the side. And I'll do the outside now. Do these 2 here. And I'm starting to get a little crowded down here because I haven't done all my sides. In fact, I probably dimensioned that in wrong for what I'm doing. So if you need to adjust your dimensions, actually you can take these little blue dots and move them, and move them. And then I gotta go back and modify this guy so he matches. Because I'm doing the outside, because that's what I did here. And then I'm gonna do my wall thickness. Now the diameters for this wall are important because it has to fit in the part. So I have to dimension that separately. But the wall for the battery, that's consistent. So I'm gonna do my dimension from side to side. And I'll pull that out. Notice this one it's not a spot point. So I'm showing this dimension here. So I pull this out. And behind the text, I'm going to add a space and in capital letters TYP period. That equals, which means this whole wall is the same thickness. That entire battery outline is 0.1. Okay, the whole thing. Now I notice I don't have my leading zeros. Oh, that's so sad. I better fix that while we're at it. Make things right. It's back in my options. Document properties, dimensions. And I need a leading zero. Let's see what we can find where that one's at. Include leading zeros. So we put a check mark there. Hit OK. Huh, I didn't do it. It didn't do it. I hit cancel again, didn't I? Probably. Less than 1 inch. What else did I miss? What was the other? Zeros. Okay. Show. Okay. So leading zeros. We're right there. So I hit OK. There they are. So I want that leading zero in front because in the United States, we do a lot of Xeroxing still. Okay. So I want that leading zero. Okay. That top part there is fully dimensioned. The sides then, the only dimension I'm going to get on the sides are heights. So I'm going to have an overall height. It's going to go between because it's the same for both. And then I'll do another one from there to there. And that would go to that point. Same for both. Now, there's a lot of room left on this sheet. So I would put a label underneath them. And I'll just put it right here because they go together. This will be the battery slot where I can see what I'm typing. And again, I'm changing that font. And hopefully I can keep my internet connected here before we lose Zoom again. I'm not quite sure what's going on today, but it's what it is. So because it's the title, this goes to 0.2. Adjust the title the box for size, and that goes right there, so it's labeled. That means I can bring another part in here and put 2 parts on one sheet. I want you to do that. I want you to make sure your sheet is full. Okay, I am going to stop here because that dimensions everything I need on this first piece, and we'll do more on I'll edit my title block probably while you guys are working, and then let you guys do some work time because some of you have a lot of questions you have that you need to ask, and keep it moving that way. Okay, so that's the lecture, dimensioning title blocks. We have a lot of that to put together, and I just noticed I don't like something. So that 0.44 is inside of this. This is an extension line right here. This is the dimension line with 2 arrow terminators. This is the dimension itself. So I'm looking at that, and it's kind of hard to see what's going on there. I'm going to move that text out to the outside a little bit, just so it's not, I don't want lines running through it. So I'm just going to position it so it's easier to read. Everything has to be easy to read. So look at it 3 times if you have to. make sure it's easy to read. Okay? All right, so things that fit together, limit dimension. What's the smallest it can be? If it's at that point, then what's the biggest it can be? And I'll help you with each of those as you need them on that. And so that's one piece fully dimensioned, ready to go. Okay. And that's my sheet. All right, let's start with online questions you guys have. Nope, not a one. Okay, the rest of this time is yours to work. Again, upload them to the course if you're ready to print. Please let me know what color you want. We're just about out of black. Actually, we're not. There's more black. So if you want black, I can still just have to use a different machine. I'd like for those of you here to do your own stuff and print your own. So the print room is open. So I can come around and help you with that. If you're at home and you're not going to be here for a couple of weeks, then by all means, let's get them printed so they're ready to go and see things happening. Okay. All right, online guys, I'm going to go and help the class real quick. And again, if you need anything, turn your mic on and yell, and I'll run back over to you. And we'll go that. Okay, back in. Caden's coming back in. Let me get Caden in, and then I'll go and help answer questions. Okay, Caden, welcome back. We are moving into a lab session now. I will have this recording posted as soon as possible for you, and we'll go from there.
Okay. Okay.
Okay,